Hey folks, welcome back to another video. Today we're looking at question 7 and 18, maximum length of repeated subarray. The way we'll be solving this question is by using dynamic programming. If you folks haven't heard of dynamic programming before, it's basically a method of using a sub-solution to come to the solution of the entire problem. It becomes a little easier to understand once we start writing it. So let's get the sizes of the arrays first. So we have n and then we have m. And this will give you the length of the two arrays that are given to us. So usually in dynamic programming, since we are building up on a solution based on the sub-solutions that we've seen, we need to store the values of the sub-solution, and in this case we'll be storing the values of the sub-solution in the array. And usually if you see problems that use DP, which stands for dynamic programming, you will see that the arrays are even named as DP, and the size would be, let's initialize that to n+1, and we'll see why it has to be one size greater than the given sizes. So once we have the setup, we need to start a for loop. Let's actually start that with I less than or equal to n. We keep incrementing I, so this iterates to the first array. We have another for loop, which iterates to the second array, int j equals 1, j less than or equal to m j plus plus. So basically here what we check is if nums of I and minus 1 is equal to nums of 2 j minus 1. What we need to do is that dp of I of j becomes 1 plus dp of I minus 1 j minus 1. So what are we doing here? What we're doing is that we're looking, since our indices here start with 1 and 1, you check for values that start with 0. So that's the reason why we have minus 1. But when you're storing the values, you actually look at if the values are same for a given index. We see that if the previous indices also match, that means it is the previous value plus the current value. So the current value will always increment the number by 1, and the previous value can be taken from like the previous number. So it'll be I minus 1, j minus 1. So that's the previous index. We could possibly have a complicated case where it's like, oh, if I is equal to 1 or j is equal to 1, just take the value as 0. But since we have initialized the array to n+1 and n+1, even if we start with array like 1 and 1 right here, because those are the values, it's basically looking at dp of 0 of 0, basically that which is pre-assigned as a 0 value. So you are adding 1 to the 0th value, basically meaning that we haven't seen anything before, but this is the first value that has matched, so I'm adding 1 to that. This is actually a very like a most basic solution that you can implement for like a DP solution. If you understand how this works and you can visualize it, it definitely becomes helpful for more complicated DP problems. So once we have this, all we need to do is actually, oh wait, so this keeps a track of, so assigns whether the current values match or not and updates the value accordingly. But the other thing that we need is actually to have like a max value. So basically what you're trying to do is you're trying to keep a track of the max value that you've seen so far. So once you've assigned the value, you check whether the given max that we have updated, if that is the max value or dp of I of j. Right? Yeah. And then in the end, you just need to return max. Right, so let's try compiling this and see if this is okay. Okay, the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity. Um, since we are using two for loops, the time complexity would be like n square or n multiplied by m. And the space complexity would also be n multiplied by m or n square, since we are using a 2D array to store all of the values. Awesome. If you have any questions about this problem or the solution that I used to solve, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I would really appreciate that. It definitely keeps me motivated to make more videos. Thanks so much, and I'll see you folks in the next video. Peace.